So here is the problem for pitch factor. An alternator has 18 slots per pole. Okay. Solution, let us write down the given data. Okay, we have to take the given data first. Okay, the given data is, it has mentioned that an alternator is nothing but a generator. Okay, generator, it will be come in 5th unit. Okay, so for time being let us understand alternator is a generator, 3-phase generator. Okay, now it has 18 slots per pole, that means 18 slots per pole means nothing but slot pitch factor, pole pitch. Slots per pole means nothing but pitch factor. Sorry, slots per pole is nothing. 18 slots per pole. What does it mean? It is nothing but our pole pitch. It is equal to pole pitch. Okay, and the first coil lies in slots 1 and 16. That means there are 16 number of slots. Actually, the pole pitch is 18. That means for a full pitch winding, you have to keep one coil side in the first slot and another coil side in the 19th slot. Actually, after 18 slots. Okay, but here it is kept. The other coil side is kept in 16th slot. This is 16th slot. Okay, the coil sides are placed in first slot is placed in the first slot, one coil side is placed, and in the 16th slot another coil side of the coils are placed. That means this will be the structure of that coil. Okay, there will be it will be having so many number of turns. Okay, but there will be two terminals came out. Okay, so this is my one coil side, this is another coil side. Okay, this coil side, whole coil side is placed in first slot, and this whole coil side, which is having 3 number of conductors, is placed in 16th slot. So that is what it means. Okay, now let us see. So this is the given data. Then we have to calculate pitch factor. Okay, Kp. Okay, we know that pitch factor is Kp, which is nothing but cos n times alpha by 2. This is the actual pitch factor value. So n is here, n is nth harmonic. You can write it as nth harmonic. Okay, n is nth harmonic here, and alpha is, we know that it is a chording angle. It is chording angle. Okay, alpha is chording angle. N is nth harmonic. Okay, now let us see what is the calculate pitch factor for fundamental component, third harmonic component, and fifth harmonic and seventh harmonic component. That means for fundamental the value of n will be equal to 1. This is equal to 1. For third harmonic it will be n equal to 3. For fifth harmonic it will be 5, and for seventh harmonic it will be 7. Okay, just you have to do. So solution will be Kp equal to cos n alpha by 2. So we have to find alpha here. How can we find that? Here he placed another coil side in the 16th slot. Actually the coil span is 18 slots. Okay, that means our second coil side should be placed in our 19th slot. Instead it is placed in 16th slot. So what is the gap here? How many number of slots will be there between? There will be 3 number of slots between 19th and 16th slot. Okay, so that will become alpha will be equal to our 3 times gamma. Gamma is nothing but slot angle. So slot angle should be calculated first. The slot angle gamma equal to 180 by number of slots per pole. Okay, so I am finding the gamma here. Gamma is equal to 180 by number of poles are not given. So it will be number of slots 180 by slots per pole. Okay, the slots per pole given as 118 here. That means 180 by slots per pole is 18 here. Okay, the gamma will be 10 degrees. Okay, each slot is having 10 degrees. The slot angle, this is slot angle. Each slot is having 10 degrees angle. So our alpha will be 3 times gamma, that is 3 times 10 degrees, that will be equal to 30 degrees. Okay, our alpha is 30 degrees now. So you can find out the values. Our first question is fundamental, that means n equal to 1 here. So our Kp will be equal to cos 1 times alpha by 2. Okay, so that will be equal to cos alpha is 30 here, 30 by 2. So what is cos alpha by 30? So cos 30 by 2 is 0.966. So this is the fraction of pitch factor that should be multiplied to get sharp pitch winding EMF. Now let us find out whenever we have to eliminate third order harmonics. So to eliminate third order harmonics, the n will be 3. Okay, so the Kp will be equal to cos 3 times alpha by 2. Okay, so that will be equal to cos of 3 times alpha is 30 degrees here. Okay, 30 degrees by 2. So 3 into 30 will be 90. 90 by 2 is 45. Cos 45 is 1 by root 2, which is nothing but 0.707. Okay, so now let us find the third one. In order to eliminate fifth order harmonic, what is the pitch factor here? Kp equal to cos 5 times alpha by 2. That will be equal to cos 5 times 30 by 2. That will be equal to 150 by 2 will be equal to cos 75 degrees. So what will be the value of cos 75 here? That is 0.259, and you can see as the angle of the cos is increasing, the value cos will be decreasing. Okay, as it is angle cos 15 to cos 45, it is the value is reducing here. Okay, you can observe that. Now let us find the last one, that is fourth problem, that whenever n is 7, so the Kp will be equal to cos 7 times alpha by 2, that will be equal to cos of 7 times 30 by 2, that will be equal to how much is the angle? It is around 105, see that cos 75, which is equal to 0.259. Okay. So for fifth and seventh harmonic, the Kp is equal 0.259 and 0.259. So this is about finding pitch factor for different types of harmonics. Okay. Now let us see here our Kd distribution factor will also be having an expression for sin m gamma by 2 should be multiplied with our n. Okay, it is multiplied with the angle. Now m sin gamma by 2, m sin gamma by 2. So this is for nth order harmonic, Kd for nth order harmonic. Okay, sin n times m gamma by 2 by m sin n times gamma by 2. So this is for nth order harmonic, Kd for nth order harmonic, Okay, our distribution winding will also be having harmonics. Actually our distribution factor will have to eliminate our higher order harmonics. This is to eliminate higher order harmonics. Higher order harmonics means 9th, 11th, 13th, 7th, like that. So these harmonics will be eliminated by Kd. Our Kp pitch factor is eliminating high dominant harmonics. Our pitch factor is eliminating dominant harmonics like third and fifth harmonics. Okay, our pitch factor will be eliminating dominant harmonics. That means most of the harmonics components, around the 70% of harmonics will be eliminated if you can eliminate third and fifth harmonic. That means these two are called dominant harmonics. They dominate all over the harmonics. So these are called dominant harmonics. These are higher order harmonics. The number is increasing from 5 to 7. So these are called higher order harmonics. Higher order harmonics can be eliminated by distribution factor. Dominant harmonics can be eliminated by our pitch factor. Okay, this is the idea. Now let us take another problem. Hello students. So this is another question. Okay, so this is one question that if you can carefully understand this question, okay, you can understand all the concepts I have covered so far. That means all the concepts I have covered in the first unit will be covered in this one problem. Okay, please be focused. Okay, keep some attention. Okay, now let us start writing given data. Okay, now let us see the problem first. Okay, the problem is saying that find no load phase voltage and line voltage of a star connected, okay, of a star connected 3-phase 6-pole alternator. Okay, our machine is a star connected alternator. Okay, star connection means it is stator connection. Okay, it is about stator connection. Okay, it is an alternator, that means a generator. Okay, it is a star connected, stator star connected generator. Okay, 3-phase generator which runs at 1200 rpm. Okay, the speed of the machine is 1200 rpm. The rotor at which it rotates is 1200 rpm. Okay, rotor rotates, stator will be stationary. Okay, so having a flex per pole as 0.1 Webers, sinusoidally distributed. Okay, this is one more important thing to be understood, sinusoidal distribution of flex. Okay, now its stator has 54 slots having double layer winding. It is double layered winding. Okay, each coil has 8 turns. Each coil has 8 turns and coil is corded by one slot. Now let us write down the given data first. So it is given that it is a star connected stator. Okay, star connected stator. So why do we need to write star or delta? So that because he mentioned we have to find the line voltage. So what is line voltage for star? It is √3 times phase voltage. So this is why you have to write down star or delta. So in case of delta, it will be line voltage will be equal to phase voltage. But in case of star, line voltage should be equal to √3 times phase voltage. Okay. Now and 3 phase, the number of phases are 3 equal to 3, and number of poles are 6 here. Okay, 6. Number of poles are 6. Okay, I am writing the given data. Alternator runs at speed. We mentioned speed as speed. Let us consider it as ns. It is nothing but synchronous speed, 1200 rpm. Okay, and having flex per pole. Flex per pole is pi per pole, or let us consider it as pi. Pi is nothing but flex per pole given as 0.1 Webers. Okay, and it has the stator. That means the stator is having this rotor. Okay, the stator is having a slots like this. The number of slots are, if this is first slot, the number of slots, it has 54 slots. Okay, it has 54. This is 54th slot. So 1, 2, 3, 4, go on, keep, and so on. It will be up to 54 slot. Okay, the stator of the machine has 54 slots here. Okay, and having double layer winding. So one more important thing about double layer winding is, if this is, if I am unwrapping it, that means I am going to keep it on a plane. Okay, so I have a number of slots as 54 here. So this is my first slot. This is second, third, 4th, 5th, 6th, 7th, like this. Okay, and go on, so on up to 54 slot. Okay, let us consider up to 54 slot. Okay, this 54th slot will be before first slot, my first slot, like this. This is my first slot. After 54, the 54 will be before first slot. Now it has 54 slots and it is double layer winding. Okay, let us see the number of slots per pole. That means pole pitch here. Number of slots per pole is 54. Number of slots are 54 by number of poles are 6. Okay, number of slots are 54 here. Number of slots are 54. Okay, he mentioned number of slots are 54. Number of poles are 6. Okay, number of pole pitch will be equal to 9. 54 by 6 is 9. That means there should be 9 slots between two coil sides of the coil to have full pitch winding. Because okay, these are my 9 slots. Okay, this will be 10th slot. Okay, now let us observe for a double layer winding. Double layer means there will be two coil sides in each slot. Okay, if this is one slot, there will be two decks here, upper deck, lower deck. Okay, this is my upper deck, this is my lower deck. That means I am going to keep two coil sides in one slot. That is nothing but double layer winding. Okay, so for first coil I am going to keep the first coil side in the upper deck of the first slot, and after 9 slots I am going to keep the second coil side of first coil in the 10th slots lower deck. Okay, these two are coil sides of one coil. Okay, if this is my one coil, okay, this is my one coil. Okay, this is my one coil. Okay, these two are the ends here. This is my one end, this is my another end. Okay, this is my one coil side. I am going to keep this one coil side on the upper deck of first slot and this another coil side in the lower deck of 10th slot, so that I will be having a full pitch winding. Okay, if I keep this at a distance of 4 pitch, that will be full pitch winding. Okay, so this is nothing but double layer winding, and each and every slot will be fulfilled with two coil slots here. If another is upper is coming out of the plane, lower will be going into the plane. Okay, this process will continue and each and every slots will be fulfilled here. Okay, that means you can see that each and every slot is filled with two coil sides. That means two coil sides will contribute one coil. That means you can see number of slots are equal to number of coils here. Okay, each coils, two coil sides will contribute one coil. Okay, so two coil sides are placed in one slot. That means one coil is being placed in one slot. That means number of slots equal to number of coils in double layer winding. Okay, winding I am writing here YDG, WDG. So for a double layer winding, number of slots equal to number of coils, because two coils are being placed in one slot. So two coil slot sides will be contribute one coil. That means number of slots will be equal to number of coils in double layer winding. For single layer winding, we will be keeping only one coil side in one slot. That means the number of coils will be equal to half of the number of slots, and the number of coils will be half of the number of slots in single layer winding, because two coil sets will contribute one coil. Okay, so I am going to keep only one coil set. That means there will be half of the slots, the coil number will be half of the slot in single layer winding. So this is about double layer and single layer winding. Number of coil, this is important, number of slots will be equal to number of coils, not number of coil sets. Okay, number of slots equal to number of coils in double layer winding, but number of coils equal to half of the number of slots in single layer winding. Okay, so this is about double layer and single layer winding. Now let us see the problem. So this is about double layer winding. Each coil has 8 turns. That means each coil, one coil, this is my one coil, it has 8 turns. This is one turn. Okay, one turn, two conductors. Okay, one turn has two conductors, it has 8 turns means, okay, this is one turn. Here it is second turn. So my second turn is over. This up to this is my second turn. This will be third turn. Third turn is over. This will be fourth turn. Fourth turn is over. Fifth turn. Sixth turn. Seventh turn. Eighth turn. Okay, after 8 turns you will be having terminals came out. Okay, this is for terminal 1, terminal 1 dash. Okay, that means our coil has 8 turns here. 1, 2, 3, 4, 5, 6, 7, 8. It has 8 turns. This means each turn has two conductors. One is this side, another is this side. Okay, this is about a coil. Okay, our each coil has 8 turns here. 8 turns individually have two conductors in each turn. Okay, so number of conductors will be, now each coil has 8 turns. It has 8. Each coil has 8 turns. Now let us see. Each coil has 8 turns and coil is carded by one slot. Okay, coil is carded. That means we are having alpha here. Okay. Now let us observe the question clearly. Find the no load phase and line voltage of a star connected 3-phase 6 pole alternator. That means we have to find out the no load phase voltage, which is we always write as 4.44 N pi F. Here N is number of turns per phase, okay, and phi is flex per pole, okay, and f is the supply frequency. So this is the thing we have to find, okay, this is the thing we have to find, E phase. And you can also have to multiply, because here in the question he mentioned it is being carted by one slot, that means we have to multiply Kp here, okay. And you can see here number of, if we can calculate the phase spread, we can find out our winding is distributed or concentrated. So phase spread is nothing but m equal to number of slots per pole for phase, that equal number of slots are 54 here, poles are 6, phases are 3, okay, that will be equal to 3 here, okay. Here 6 9 ja and 3 3 ja, it is 6. That means if this m value is 1, if m value equal to 1, this means the winding is concentrated. Concentrated means number of coils belonging to one phase will be placed in one slot under one pole, that is nothing but 1. If m value came as 1, we can assume it as the winding is concentrated, but if it is more than 1, we can say it is distributed winding. That means here m is 3 here, that means we can confirm it as the winding is distributed. So for a distributed winding, we have to multiply Kd with our EMF equation, so that this is the EMF equation we have to find, okay. So this is the beauty of this question, we have to multiply Kp because our coil is parted by one slot, that means we are getting alpha here, okay, carding angle, and here the m value is 3 and it is not 1. If it is 1, we can assume it as concentrated winding, but it is 3 which is more than 1, so that we can understand that the winding is also distributed. So for a distributed short pitch winding, we have to multiply two coils, two factors. For a distributed and short pitched winding, we have to multiply with Kp and Kd. So these two multiplication is called winding factor Kw. Kw is nothing but Kw is winding factor, okay. Kp into Kd is called winding factor, okay. Here you can replace this Kp into Kd with Kw. Here Kw is nothing but a winding factor. Kw equal to Kp times into Kp into Kd, okay. This is one more factor. Kw is nothing but product of Kp and Kd, which is multiplied with EMF equation of a concentrated full pitched winding, okay, to get for distributed and short pitch winding. So this is the idea, okay. Now let us find out our Kp and Kd, so that we can multiply with our EMF equation, so that we can get phase voltage and line voltage, okay. For that we have to get these things. Here n is equal to number of turns per phase, okay. So here what is number of turns per phase? Here it has 54 slots, for it is a double layer winding, that means it will be having 54 coils, okay. 54 slots means if slots is 54 for a double layer winding, okay, double layer winding, the number of coils are also 54, and each coil has 8 turns here. 8 turns will be equal to into 8 here, okay, and you will be having it will be divided by 3, okay, and number of conductors, to get number of turns it will be divided with 2, okay, because one turn has 2 conductors, so the whole number of turns per phase will be equal to 72, okay. We got n value equal to 72 here. Now let us calculate pi is given as 0.1 Weber. We don't have to do anything. Pi is nothing but flux per pole, okay. We have frequency, we have to find the frequency. Did he mention anywhere frequency? No, he didn't mention frequency. So we can find out the frequency by using our synchronous speed 120 f by p, okay. So here the synchronous speed mentioned as 1200 rpm revolutions per minute, okay. That will be equal to 1200 revolutions into 120 into frequency by number of poles are 6. So you can get it as 60 Hz, okay. 120 into 1200 will be 10 into 6 60 Hz, okay. Our frequency equal to 60 Hz here, okay. We got frequency, flux per pole and number of turns per phase. Now let us find out Kp and Kd here. So the Kp is equal to cos alpha by 2, so we need to find alpha here, okay. What is the slot angle here? It is carded by one slot, so that if the alpha will be equal to gamma here, because one slot angle will be equal to one carding angle, so gamma is nothing but 180 into number of poles by number of slots, that will be 180 into number of poles are 6 here, number of slots are 54, okay. Gamma will be equal to 6 9 ja 9 2 ja 20, so gamma is 20 degrees here, okay. Gamma is 20, so the coil is carded by one slot, that means our alpha will be equal to gamma, that is 20 degrees, okay. Our alpha is 20 degrees here, okay. So Kp will be equal to cos of 10 degrees, 20 by 10 will 20 by 2 will be 10 degrees, so our Kp will come with 0.98, Kp value is 0.98, okay. These are the values. Now we have to find the Kd also, okay. Kd is nothing but sin m gamma by 2 by sin m gamma by 2 by m sin gamma by 2, okay. So I am erasing the question here, Okay, did we have anything? So we need to find no load phase voltage V phase and line voltage. Line voltage is nothing but root 3 times phase voltage. If you can find phase voltage, you can find the line voltage. Okay, so this is about. And one more thing here, the flex distribution is assumed as sinusoidal. Okay, the flex distribution is assumed as sinusoidal. So let us understand that concept. Okay, flex distribution, that means rotor is having number of poles. Okay, the rotor will rotate continuously. Okay, our stator winding will experience some magnetic field. Okay, if this is my stator, okay, I am assuming it as stator. So this will be rotor. Okay, here our rotor will be induced with stationary poles with DC excitation in case of alternator. So on the stator we will be having number of slots on the periphery of the stator. Okay, so these are the number of slots I have for an alternator. Okay, so these are the number of slots. So here you can see at this point I am considering this point A. Okay, at this point what is happening? Let us see. Okay, so at the point A, the magnetic field produced, the magnetic field experienced by this slot is 0 here. Okay, because the magnetic field is in this direction. Okay, the magnetic field is in this direction, perpendicular, and it is not cutting any conductor here. Okay, the magnetic field is 0 here, experienced by conductor A in the slot, in this slot. Okay, now let us assume it is 0, and as our rotor is, let us consider it is rotating in clockwise direction. So as our magnetic field is rotating in this direction, you can see our magnetic field is coming near to our point A. That means the magnetic field experienced by conductor A is increasing gradually, and it will come to, whenever our north pole is at this position and south pole is at this position, you can see maximum amount of flux is being cut by this conductor A. That means this is a maximum amount condition. That means after 90 degrees rotation. Okay, initially let us consider it is 0 degree rotation. After 90 degree rotation, the flux experienced by conductor A is maximum here. So after this, our north pole will become here and south pole will become here. Okay, that means after 180 degrees, that will again be 0. That means no flux will be cut by this conductor. So this process will continue on this, and the magnetic field experienced by our conductor is sinusoidal. You can see. Okay, so this is about sinusoidal EMF, sinusoidal flux distribution, and you can see here this part of the stator is called slot tooth. This is slot where our conductors are placed. Okay, so my conductor is placed here, and this is tooth. Okay, here you can see this tooth will experience a magnetic field which is more compared to our conductor, because our conductor is kept in depth compared to the tooth. Okay, our conductor in slot will experience less flux compared to the tooth, because tooth is coming first to the flux, after that only our slot conductor is coming. That means our flux distribution will be like this. Okay, for tooth it is like this, and for slot it will be like this. For tooth it is like this. So the flux distribution is not uniform, actually not sinusoidal, it is like something like this. Okay, it is not pure sinusoidal because of the tooth. These are called tooth harmonics. Due to the tooth harmonics, our flux distribution is not sinusoidal. Okay, this is one point. Okay, due to the harmonics, these harmonics, our EMF will be distorted from sinusoidal wave. Okay, in order to eliminate them, we are keeping Kp and Kd. So this is the idea. Okay, now let us see what is Kp, Kd, right? So Kd is sine m gamma by 2 by m sine gamma by 2. So this is expression for Kd. Okay, now let us find the Kd. Kd is nothing but Kd sine m is 3 here, gamma is how much? 20 by 2 by m is 3 sine 20 by 2. So if you can put these values in calci, you can get the value as 0.96. So my Kd value is 0.96. Okay, so we have the value for n as 72 and flux as 0.1 Webers. Okay, the question is to find the phase voltage, no load phase voltage and line voltage. If you can find the line voltage, you can multiply root 3 so that you can get line voltage for a star connected stator. Okay, so flux is 0.1 and frequency is 60 Hz. Okay, and our Kw is nothing but Kp into Kd. Okay, so Kp is nothing but, what is the value? 0.98 and Kd equal to 0.96. So you can multiply all these values so that you can get no load phase voltage E phase equal to 4.44, n is nothing but 72 here, pi is 0.1 Weber per pole, f is 60 Hz, Kp is 0.96, Kd is 0.98 and Kd is 0.98. Kp is 0.98, Kd is 0.96. Okay, so the no load phase voltage value will be equal to 1805 volts. It's equal to 1805 volts. This is my answer number 1. This is my first answer. Okay, this is my first answer. So now let us find out the line voltage. No load line voltage equal to root 3 times phase voltage, E phase, because it is a star connection. Okay, our no load line voltage will be equal to root 3 times phase voltage. That will be equal to root 3 times 1805. That will be equal to 3125. volts. Okay, so this is about KP, KD, double layer, single layer, and flux distribution, and number of slots, and full pitch, short pitch, okay, pole pitch. So this is about this. So I hope you have understood each and every concept here. If you have any doubt, you can contact me. You have my mobile number placed in the LMS. Okay, so this is about our first unit. Okay, I'm going to conclude this first unit here. Okay, the rest of the content in the first unit will be explained in 5th unit further. Okay, thank you.